So let's say the structure that we're gonna go for is a dictionary. So I'm gonna say a dictionary. Of course, an empty dictionary is a dictionary itself. Let's say type of D, it's always gonna be dictionary. So again, it's defined in curly braces. What is the difference between a dictionary and all the other? It is very similar to something like a normal dictionary. Like if you would go for an English dictionary, you would select for word, and then against that word a meaning would be given. In a similar manner, here a dictionary can be defined with keys and values. You can give a key. Let's say, for example, in a list, the index was always 0, 1, 2, 3, 4, 5. No, that's very sad. I wanted something like, because my students' roll numbers can be very different. It doesn't start from 0. No roll number starts from 0. It starts from 1. And I don't want to store all the roll numbers. I just want to store 5 or 6 of the roll numbers. But against each roll number, I require to have their names. If I would just have L is equal to a list of names, it could be just like, ABC, comma, XYZ, comma, and so on. But then still, if I have to access L of, the first element, I should access it L of 0. I didn't want to access like that. I just want to call it with the roll number. Then what will I do? I should define a dictionary. Let's say, one second, a dictionary is equal to, D is equal to, define curly brackets. And say there, what is the roll number? Let's say 10. The roll number is 10, and ABC is the name corresponding to roll number 10. Okay? 12 is XYZ, comma, 9 is DEF. So if I print the dictionary, can you see, is it ordered or unordered? Unordered, of course. Can you access them with D of 0? No. But what is the error that it gives? It gives you an error called as key error. What is a key error? A key error is that error which would, it is an error which says, no, that, this cannot be done this way, or we can say a key error would be that error which says, there is no such key in this particular dictionary. Let's say there is no 0. So I can define it with D of 9. You could give me the value, DF, yeah, there is a key like that. D of 10, oh yeah, there is a key like that. But D of 11, no, there is no key like that, key error. D of 12, yes, there is. The value is XYZ. Can I add elements? Is it mutable? Yes, D of 11 is equal to, let me say, GHI. Oh yeah, 11 also got added to that. So we can add things like that. Now, if I iterate over it, if I say for every I in D, if I just do this, and if I just print I, it prints me the keys. It does not print me the values. I could have printed the keys also in another way. For every K in D dot, I can get keys. D dot keys method, I'll use that. And if I print the K, it will again give me the keys. If I want the elements along with it, I should print what? K, comma, D of K. That will again give me key along with the value, right? Or I could say for every E in, I want the element. Then I should say, instead of D dot keys, I should say D dot values. D dot values, colon, enter. I should print E. This will now give me only the values. Correct? Instead of D dot values, instead of D dot values, I could also say something like this. For every, for every X in, what is it? I would say D dot. Instead of values, there is something called as items. D dot items. And now if I print just the X, what do I get? X is what? X contains the key and the value together in a tuple. Can you see? You get them together in a tuple. So each of them are tuples, having keys and values. So I can unpack them in the for itself. Instead of saying for X, now I'm sure that X is what? It's a tuple. So I should take them in key, comma, value. I can take them like that by unpacking them. Then I can print the key, comma, value. Each of them I unpack them. Now I'm not printing a tuple, but I have my key in K and my V in V has a value for every iteration. Is that clear? Yes. So with that, we have covered the data structures which are required for our Python analysis, for our IoT analysis. As we go ahead, we have to create our own data structures for now, that is classes. Creating our own data structure and then trying to develop them and trying to figure out how to apply them in Python a little later. So in IoT a little later. So now we'll be done with Python in another half an hour or 1 hour of the video, and then we go on to learning how to apply them on the Raspberry, make things work on the Raspberry, make some intelligent stuff, and then proceed ahead, right? Cool. With this, we complete over here and we go on to classes and objects in the next session. Thank you.